Again, I really couldn't resist doing a couple from chapter 9 from the Assess, just to really finish off unit 1 at the higher level. Going into page 137, this is Assess 9, and we're looking at question 5 straight into grade A. By the way, question 4 I've done in previous foundation videos. It's a lovely question and it's worth your attention, so do click on those links. Question 5, the probability Callum has to work overtime on a given day is given by 0.12. So let's just do Callum. Right then, the probability having to work overtime, there you go, is 0.12, and the question says, what is the probability that he has to work overtime on 2 consecutive days? Okay, probability of 2 overtime days is going to be 0.12 followed by 0.12. I know 12 is 144, 0.0144. Because I'm very unconfident, I'm going to check it on my calculator. 0.12 squared, where's that? Squared, yes. Now, that's the first bit. The second bit asks, what assumptions did you make to the answer in part A? So that was part A. Now, I had to assume that overtime on one day is an independent event, as distinguished from overtime on any other day. In other words, Callum can't work overtime Monday and then his boss says, actually, I don't need you on Tuesday because you worked on Monday. That'll be conditional and therefore dependent. So I'm having to assume that each day's overtime is independent, and therefore I can multiply 0.12 by 0.12. So I just write the word independent here. It's an independent event. Alright, next question. Oops, I'll come on to that later. Right, next question. I fancy doing question question 7, rated at A star. Right, Maria plays tennis better on grass than any other court. On grass, when she plays, she's got a 75% chance of winning. Right, so here we go. So grass win equals 75%. I don't like that. We're going to call it 0.75 and stick it as a decimal. And on other courts, she has a 60% chance of winning. So other, I've got 60% chance of winning, otherwise known as 0.60. So it looks in keeping with that one, just above there. She plays 45% of her games on grass. So 45% on grass. In other words, 0.45 is the probability of her playing on grass. And it says, use a tree diagram to find the probability that she will win her next game. Right, so let's do it all nice and thick. What do we got? She could play on grass, or she could play on another surface. If she plays on grass, she could win, or she could lose. If she plays on other courts, she could, of course, win. But then again, she may lose. Let's take this down a notch. And here we go. Alright, the probability of playing on grass is 0.45. So the probability of her not playing on grass, in other words, playing on another surface, is 0.55. Again, both the branches will add up to 1. You can either go, you can either go one way or the other. That's good enough. Alright, now if she plays on grass, the probability of her winning on grass is 0.75. Therefore, the probability of her losing on the grass must be 0.25. If she plays on another court and wins, probability of that is 0.60, and therefore the probability of her playing on anything other than grass and losing would be 0.4. So put 0 there so it's all complete. Right, the punchline is, use your tree diagram to find the probability that she will win the next game she plays. We want to win. So if we go on grass, we're going to go grass and win. So it's going to be 0.45 multiplied by 0.75. Get my machine on that one. 0.45 multiplied by 0.75. Oops, pressed the wrong button. 45 multiplied by 0.75. We've got 0.3375. Now, I never do fives properly. Now, to win in the other court, we're going to go down this route and then up there. Okay, so other court and win. So it's 0.55 multiplied by 0.60, and we have got 0.55 multiplied by 0.6 gives us 0.33. So therefore, the probability of a win, whether it be on grass or on some other surface, is going to be 0.3375 or 0.33 dead, and that will give us 0.6675, and that, my friends, is the answer to that one. Now, last question, I think. Question, yeah, I've got that, it's beautiful. Last question, I really fancy doing the exam question. Well, the simulated exam question. There it is there on the screen. It's got at the end of a training course, candidates must take a test in order to pass the course and obviously walk off with some sort of lovely certificate. The probability of passing the test at the first attempt is 0.8. That's what you've got there on the tree diagram. And those who fail the test can resit it just the once, and the probability of passing the resit is 0.5. Okay, so we've got 0.8 pass first go. Therefore we have 0.2 if you fail. If you fail the first go, you can retake it, and the probability of passing is only 0.5. And the probability of failing again is 0.5. Again, these two branches add up to 1, these two branches add up to 1. Complete the tree diagram, done it. What is the probability that a candidate fails both attempts and so fails the course? Okay, so looking at the probability of fail followed by a fail, which is 0.2, that one, followed by that one, failing again. Well, that is 0.1. Half of 0.2 is 0.1. That's done. Now that's B sorted. Right, that's A sorted. What is the probability? Yeah, done. Sorry, that was in fact A part 2. Oops, silly me. So that's A2 and that's A1. Alright, now B. What's the probability that a candidate passes the course? Right, here we go. So, the probability of a pass, we can pass in two ways. We can either pass outright, or we can pass after having failed first. So 0.2 times 0.5, let's write it up here, is going to give us 0.1, isn't it? So I can, again, I can add on my 0.8 for passing first time round onto my 0.1 from passing the second time round, and that will give us 0.9. Okay, good chance of passing one way or the other on the first or second attempt. Now we've got two characters. We've got Hassan and Louise, both take the training course. What is the probability that one of them passes and one of them fails? Okay, so let's just take a look at that. I've got Hassan, I've got Louise. Just do a little chart to see what's going on here. We can have pass or we can have fail. Alright, now let's just take a look at that. Hopefully I'm not in the way there. Now, for Hassan to pass, he can pass, how can he do it? He can pass by going 0.9, and therefore for Louise to fail, that will be 0.1. Or for Hassan to fail, that will be, what do we got there? Fail followed by fail is 0.1. Or Louise can pass one way or the other, which is 0.9. Now all of these are possibles. So we can have Hassan passing and Louise failing. So we've got 0.9 times 0.1. That takes care of that little part of the two-way diagram. And the second scenario is Hassan failing and Louise passing, which is the complete reverse. So Hassan fails 0.1 and Louise passes 0.9. Working both these out, we have 0.09 and 0.09, grand total 0.18. So that's the final probability. Alright, so the probability of one passing and the other failing equals 0.18. I hope that's come out okay on the video. I hope my little box there didn't get in the way. That'll really annoy me and you. Thank you so much. The course is in fact over. Start checking out Unit